Hey everybody, Phil here, Zon Master and Ruby on Rails and all the rest of that. And today it's another Ruby on Rails tutorial, as I seem to be wont to do on this channel. And today we are talking about Elasticsearch and how I love it. All right, so the basic idea of what I'm going to do today is I'm going to introduce you to Elasticsearch and how to incorporate it into a Rails app. You presumably know what Elasticsearch is, but if you don't, it's a document-based database engine. So kind of like a NoSQL type database, I guess you would call it like that. It's highly indexed and easily queryable, and it doesn't deteriorate so much over size. So when you have a massive number of records, it keeps on going. So what I've actually started to do in large projects is have two databases. One kind of like the source database, and that's a traditional, relational database system, let's say like MySQL or PostgreSQL or something like that. So that'll be underneath, and data that comes in gets consumed and is kind of stored in that database as a raw data store. But data that's shown on the website, most of that data, ideally all, comes out of Elasticsearch. And what I do is I have triggers and jobs that you'll see a little bit how I do that. When the data is updated in the relational database, we are updating Elasticsearch, so those data are pretty much in sync. And the beauty of Elasticsearch is that you can kind of denormalize data, collate data, so that you are generating from Elasticsearch pretty much exactly what you need for the front end. So it's pretty exciting. I don't know why more people don't talk about it. Maybe people do talk about it and I just don't see it. But it's a pretty cool way to work. And so what I'm going to do right now is create a new Rails app, install Elasticsearch into that, create some dummy data, show you how that is indexed and how you denormalize and all of that stuff. That's what I'm going to do in this video. I don't think I'm going to have time to get to other uses of it and things like that. Maybe I'll do another video if people are interested. But this should be kind of a beginner to intermediate workup on Elasticsearch. So let me switch over and let's get into it. Sorry for my hair. Do I say that every time? I don't know. All right, so here we are on the old Macintosh. I have Homebrew, as I think every Mac user does, every Mac developer does, to install packages, and it's using Homebrew that I have installed Elasticsearch and Kibana. And if we do brew services, this beyond the scope of this tutorial is how to install Elasticsearch. Brew services list, and let's just gripe that to Elastic. And so we'll see that we have Elastic. I use the OSS versions, Elasticsearch, and we have Kibana. I don't know why I'm just not showing all of my services. That'd probably just be easier. So yeah, Elasticsearch, Kibana, Memcache is running. I'm not using it in this, and I'm going to be using my MySQL 5.7, I guess, I've got running on here. So let's create a new app, right? So let's Rails new Elastic app, and for a database, I'm going to use MySQL. And let's let that generate. And sometimes, I don't know why, I've got this like 2020 maybe, or 2019 MacBook Pro, and it sits, and you'll see it sits there. And this is where I'll drink tea. Yeah, let's talk about Elasticsearch for a second while this thing is doing what it's doing. So yeah, a document-based database system, and I find that for me the big advantage, well, there's two big advantages as to why I'm using Elasticsearch so much. One is This is not really an advantage of Elasticsearch, it's a disadvantage of MySQL. MySQL, you can put a ton of data in there. I mean, I've got hundreds of millions of rows and things like that. That's fine. But if you have 100 million rows in a MySQL database and you delete 99 million, your database doesn't actually shrink in size at all. So we have this ever-expanding database. Even if we're deleting old customers and all of that, it's ever-expanding in size, and that really infuriates me. So ideally, I would like to get rid of MySQL, but it's hard to get rid of it. So it also slows down over time, and you really have to make sure your indexes are tweaked correctly for the searches. So that's a problem with MySQL. Using Elasticsearch, maybe I'm just not so very smart, I don't know, but with Elasticsearch, pretty much everything is indexed, first of all, so you don't have to worry about that. It seems to free up space when you delete documents. And it doesn't bog down or change so much based on how much data is in there. It changes more based on how much data you return. So if you have a honking big Elasticsearch database and you search on something and you only return 2 records, okay, that takes 10 milliseconds. If you search on something, even on a huge 100 million document Elasticsearch database, if you search on something that brings back 100,000, of course that's going to take a long time, but that's the piping of data, even on a local machine, piping of data between the two. So ideally you won't do that. You can use something called a scroll cursor and all the rest of that stuff. We can get into more sophisticated Elasticsearch stuff sometime if you want. This is what I'm up to right now. I don't know if I'm going to cut all this out, because I don't know whether you guys... I'm going to watch the view numbers and see if we just skip over all this crap, because I'll put an index in there. It's a very beautiful day here in Japan. I live in northeastern Japan. But the interesting thing about today is about 2 hours ago, a massive tire fire started somewhere over there. So there's huge plumes of big, thick black smoke, and the windows are closed, and we have a little bit of a whiff of it, but not too bad. Okay, here we are. We're done. Thank God for that. So we have your Rails 6 app. It's just a Joe app. I'll open it up in VS Code just so we can get an idea, and I'll zoom it up, and I gotta remember that you can't see the whole screen, so I'm gonna do that, and then it's just I just want to get the sizing right here. There we go. You should be able to read that, right? I would think. Maybe I can pull it over and I'll just be careful. All right, let's go back to the console. And, we need to add some goodies here. So we're going to add, I love this bundle add command. I'm using it. I mentioned it in the other episode, and I've never seen it before, and now I love it. Elasticsearch model. So we want to add three gems. Persistence. Let's quickly pop over and take a look at the Elasticsearch-rails web page on GitHub. And so there's Elasticsearch Ruby and Elasticsearch-rails. I'm not going to delve into what the differences are, but this has some hooks for Rails and all that other stuff. And I always find that you got to put everything in there. So we're just going to put in model, Rails, and persistence, and then we'll get into that. If you want to read more about Elasticsearch-rails, I'll put the link, of course, down in the description to their GitHub, and put a link over to Elasticsearch if you need that. Elasticsearch is free, by the way, in case you're asking. So, all right, have we added it? Did I press the button? No, I didn't. There we go. So it's going to go out, and it's going to dump that into our gem file. So it should be in our gem file now. And if we look down the bottom, there we are. Elasticsearch-rails, model, and persistence. So we're going to create an initializer file. Config initializers, and we'll just add one in. Elasticsearch RB, And what we're going to do here, Elasticsearch model, and I just want to turn on logging. I'm just going to copy in something that I've got before. You can just see what I've got here. So we're just replacing the client, and the client is the thing that actually goes out and connects to your Elasticsearch instance. You don't have to do this, what I'm doing, it's just that then it'll write everything. So adding logging, and we'll do a timeout just so we don't get stuck anywhere. So, good. I think everything is fine. And actually, we're done. That's the config is all done. Now we can go back and go on with the tedious stuff of creating some models. And what I'm going to do this time is I'm not using a library example like I've been using in the other ones. I'm going to use something that's a bit more familiar to me, and that's a kind of like a purchase order thing like that. So what I've got is I'm going to scaffold an object model called purchase order with a whole whack of fields: order number, purchase date, status, sales channel, all that kind of stuff like that. Ship to name, ship to address. Pretty much what you would have in an order. So we're going to create a scaffold for that because we might want to take a look at it someday. I'm going to create a scaffold for an item, and an item or a product is the thing that you actually sell on the website. So we're going to quickly scaffold together an item which has a SKU, a title, a nickname, a price, how much is in inventory, a fulfillment fee, and a unit cost. And then finally, the way I like to work when I'm doing orders is you have an order, which is, the order, but then you have line items, because that seems to be the way that all the online e-commerce platforms work. I'm giving you a good leg up here if you ever want to do something that integrates with an e-commerce platform. So I'm going to create an order item, which is the line item. And that will belong to a purchase order. It will belong to an item, because it's a line item. It can only have one type of thing on it, though it might have multiple quantities. So it has a quantity ordered, a quantity shipped, a price, a discount, tax, and the platform fee, which will be calculated. So, bada bing, we've got our our models defined. Now, I don't know whether you need to do this. Maybe it's just an old schooly type of thing. Migrate. But what I like to do is for all of my floats, I like to create a default like this. Is that it? Float. You would think I would do them in order, so it'd be easy for me to find. There's a float there, float there, float there. So it's just a float that defines a precision and scale. Comes back to bite you otherwise sometimes. And of course, some currencies don't have, any kind of scale like that, but whatever. So, and on my integers, I like to add a default. So we'll just go through. This one's done. Let's find the integer, add a default. I don't bother to do any defaults on the other things like that. Okay, so we're all good. Now, one of the problems of doing something like this is that you need dummy data. Dummy data is such a pain, and there's no real way. I always just like to roll my own data. Excuse me. And the way I do that is by using this amazing, I love this thing, amazing gem called Faker. I'll put a thing in there. Ruby, yeah, Faker. This gem is so awesome. And it lets you do all kinds of stuff. It just generates random data and all kinds of cool data. And what I do, okay, so I haven't created the database. So let's do a Rails DB create. Now we'll see if I typed everything right or copied everything right. Rails DB create and a Rails DB migrate. Yay. And now I'm going to go into the seeds file. This is as good a place as any to put the place to seed your database. And what we're going to do is we're going to create 25 items for sale. Let's take a look at this, because this is, again, totally off topic, but not totally off topic, but a little off topic. Using Faker. So I'm going to create some items, and if we saw before, we have SKU, title, nickname, price, inventory, fulfillment fee, and unit cost. Sorry if I'm talking too fast. Sometimes I get a bit hyper when I'm excited. So SKU, we're going to create just an alphanumeric gobbledygook. We'll create, see, Faker has a commerce, it creates a product name. I'm going to use a promotion code for a nickname, which is horrible, but I couldn't think of something else. We'll create a price, can be any price, and we're going to, how much inventory is there. I'm just going to take a range of 0 to 10 and pick a number out of it. And I guess there's other ways to do that, but that's what I do. And then we're going to get a price. We're going to choose a price between 0 and $2.99 for the fulfillment fee, and the cost of this unit will be between $5 and $12.99. So it's going to fill in all that data. Then I'm going to create 5,000 orders. You can create as many orders as you want, of course. 5,000 orders. And I'm going to use a combination of Faker stuff and my stuff. So we're going to choose an order type between confirmed, in other words, they bought it, but it shipped and delivered. The purchase date, anytime in the last 30 days. Shipped at, if we happen to have chosen a shipped or delivered, then we're going to, at a purchase, we're going to ship at 3 days after the purchase date. Estimated arrival date, if we've shipped, then we're going to, 4 days after the shipping date, we'll put our estimated arrival date. Confirmed at, purchase date minus an hour, lazy. And then some fulfillment centers. There's a certain company that has fulfillment centers all around, and they have 3-letter things. So I just created some gobbledygook 3 things there, and we'll pick one of those. This is so later, inside of Elasticsearch, we can, group by fulfillment center, just to get some nice looking graphs or whatever like that. So then I'm going to create the purchase order. With an order number, I'm using a 388 order number thing, which is kind of like the way that company named after a river works. Purchase date, sales channel, I'm going to just pick a random from those. I'm creating dummy data. All right, this is a good way to create dummy data, fast and easy. You may have a better way, and maybe there's a more accepted way, but this way works. And finally, we need to create some line items in there. So for all my purchase orders, I'm going to go through, and then I'm just going to choose product at random, and I'm going to, using the num item shipped that I created up here, which is between 0 and 1, and num items unshipped between 0 and 1, or not between 0 or 1. Do that again. It's just dummy data, right? And then another price there between 12 cents and 99 cents for a platform fee, the tax, the price, which is how many units times the price of the item. Yeah, there we go. So all of this will create 25 items. It'll create, I'm going to format this a little better. 25 items, 5,000 orders, and then 5,000 order items. I didn't bother to do multiple order items, which is just a demo, guys. Give me a break. Okay, so we've created the seeds. So now we can say Rails DB seed. This will take a few minutes. If we want to see what's going on, we could pop over into another window, into a console, and we could say product order.count, and we can, purchase order. Purchase order. This is how I kill time, by mistyping things. So you can see this number is going up, so that's fine. If we look at an item, you can see we've created the items in durable aluminum pants. It's got a nickname of incredible promos. It's got a SKU, got some cool price here, 31.37, so on. I haven't done the right thing with currency, but no, it doesn't matter. There, we've got 5,000 purchase orders. And then if we look at order item, which is the line item, see what I missed? See what I missed there? In purchase order has many order items. Dependent destroy, so when the purchase order gets destroyed, the order items get destroyed. So rather than, you know what? So I can show you another one. Truncate all. Here's another cool Rails DB command. Truncate all. I think it's only in Rails 6. Wipes out our database and resets all the counters. So let's start over. Even though, well, that means we'll lose durable aluminum pants, we're instead going to get an aerodynamic marble coat. It's going to whip through the purchase orders. Doesn't take long. Could say something clever here, but I don't know what to say. You know, I even had that written down that I needed to add that line in there. So we've almost got all the purchase orders. So we haven't even started in on the Elasticsearch stuff yet, sorry to say. Just check my camera is still working, looks good. Okay, it's got all the purchase orders. It looks like it's, whipping through the order items. So that's all good. In a second, what I'm going to do here, why not? Let's fire up the Rails. And let's take a look at localhost. Let's not do that. Why don't we add a root? A root to the roots. We can do that. Now let's take a look at localhost. Let's type it right. And then we should end up on a page with 5,000. There we go. 5,000 things. Looks like I did payment method not quite right. But there we go. We've got all of our things. I haven't, did I do a scaffold? No, I didn't do a scaffold on an order item, so we can't go and look at an order item. But anyway, we've got all that data in there. I think we're all done. We're done. So now let's talk. I can put an index down there, and let's talk about Elasticsearch. That's what we're here for. How do we get Elasticsearch running. We now have a MySQL database that has all of that data in it. Nothing in our Elasticsearch at all. Elasticsearch hasn't touched anything. So what can we do? First of all, we go to our model, we include Elasticsearch model, and if you want, you can include the callbacks. And the callbacks just save you from writing an extra line. Model callbacks. And what this will do is every time your object is updated, deleted, or created, it will call out to Elasticsearch and put this in the database. Funnily enough, that's all we need to do to get an exact replica of our data in the Elasticsearch database. Now, note I say exact replica. So if that's what you want, fine. That's what you can do. Let's reload this. Let's choose a purchase order. Really wish it wasn't purple. Okay, so we have a purchase order. Now we can say purchase order. We just say touch. We can see that it is actually put it, 9200 is the Elasticsearch port. It's actually put it. It's created a index inside of Elasticsearch for kind of to compare to MySQL. It's created a database inside of Elasticsearch called, or a table, I should say, inside of Elasticsearch called purchase orders, and it's chucked this exact thing in there. It has no knowledge of the associated record. It's just a one-to-one of our data. Now, if we go over to something called Kibana, Kibana is like a Elasticsearch front end. We can create an index pattern for purchase orders. We can choose a default time of purchase date. And if we look, okay, there we have everything, is in there. So that's that easy. If all you wanted to do was replicate your info into Elasticsearch, it's done, right? Exactly like that. No more work needed. And if you wanted to pull this, we've got one in here, ID of 1410. If we wanted to pull it out of Elasticsearch, we can just say purchase order search, which is the when you add Elasticsearch model, it adds these methods in. You can use a query, match. You can tell I've done this before. ID, what was it, 1410? And the better thing, just to save time here, results first. This object now, excuse me, is out of Elasticsearch, and you can see it took 1 millisecond, and this is it. It's the ES purchase order. We can look at anything, confirm that is that date, but it's a string, of course. So what's the drawback here? However fast this was, which was probably pretty fast because I'm talking about 30 minutes there, created the Rails app, created the dummy data, created my objects, created the dummy data, put it in, have it into Elasticsearch. Great. But it's not perfect by any means. I wouldn't use it like this because, first of all, everything's a string. And second of all you're doing is replicating the data in MySQL, which is fine, but it doesn't really give us much. Though, maybe there are instances where you've got everything denormalized already and you pull it out. So let's ditch this. And okay, we can go to when you have Elasticsearch model installed, so we can go to purchase order, you get an accessor directly to the connection, which is __ Elasticsearch __, and we can delete index, and it is going to blast that index and all the data. We don't need it, and I'll show you why. What we want to do is actually format our data. Okay? And we do that by creating some settings for what the index is going to be. And there's no way I'm going to type all of this, but I'll give you the start of it. Number of shards, because all of this doesn't change. You always do it the same here. Do, end. Mapping. Dynamic, we don't want these things to change. We want to set exactly how we want our fields to be shown in or stored in Elasticsearch. So first, what I'm going to do is, again, yes, I prepared this earlier. These are all the indexes. So this is essentially what it does by default, except we are adding a type. So we're saying that the ID is of a type integer, because if we go over here and look at what came out, we can see, where's bloody ID? ID is a string. That's why it's got quotes around it, right? If I said, I may have deleted that by now, but you can see it's a string because it changes color if I say to I. So yes, you can see that it's a string. So what we can do in these dynamic mappings is say, okay, this is of type integer. For strings, if you don't do anything, like tracking number, okay, it's just a string. But for status, sales channel, payment method, though I see I've got a problem there, payment method, carrier, like who's shipping the thing, we say type keyword. And that does some optimization inside of Elasticsearch. So we can then cluster those in Kibana if we want to create some beautiful looking graphs in Kibana or whatever. You use keyword. But for me, the most important, well, I guess the integer is pretty important, that it's actually now a number. Dates, we don't need this. This is just a note to myself. If we say format date optional time, that will give us the proper, I should put that in there, the proper formatting for Rails string of a date time, which comes out looking like this, which translates to that, which in Elasticsearch looks like that. So optional time. So yes, integers, dates with a formatting, keywords, integer, half float. So for all of the float types, the prices and the money and everything like that, you can use half float or float if you have something that's really massive. And for strings that will not need to have anything special, they're just put them in there as indexed. So that will set that up. Now let's reload. And let's grab a purchase order and let's update it. Just purchase order touch. And now if you look at this thing that's gone into the database, you can see the ID is a number. It doesn't have strings, it doesn't have quotes around it. The order total is a number or a float. So let's add some more goodies onto this thing. So for instance, we would like to know some stuff about the underlying order items. So let's say what SKUs are in this order, all the SKUs, a list of the SKUs, what item IDs, because maybe we want to do links on the page, what item IDs are in this order, how many unique products, how many were ordered, how many were shipped, how many are unshipped. So we can delete the index, create the index, pick a purchase order and touch that. Now if we go back I need to go back and recreate the index pattern. Refresh this. And we should have something called skews. No, because I need to rebuild it, not refresh it. And if we discover, now if we look in here, they're not there. Now why aren't they there? Because it's all well and good. Man, I'm really screwing this up. Once we add custom fields, we need to tell it to use those fields when we save it. So I always write a separate object called a purchase, like a denormalizer. And I'm just going to create a new one here. Purchase order denormalizer.rb class. Okay, now what'll happen is that this, when we deserialize, it will call this object. The reason I create a separate object is because it can get quite huge. So let's reload. Let's, for the sake of ease, we're going to delete our index and create our index. Let's pick one and let's save it. Now, there we go. So we can see it's trying to use the denormalizer. And when we create a denormalizer, we pass in the object that we want to update. So we have an initialize of the purchase order. And why don't we create a reader purchase order, and we set it here. All right, let's reload this. Yeah. So now what we need to do is create a hash, a method on the denormalizer that will put it out. But let's talk about some other fields that we would maybe want to have on here first. Of course, the other thing, we're going to want to know the currency, and the currency is set right now on each line item, but currency can only be one currency per order. We happen to know that. And we have all these order items, but we don't want to create another index. We want to put everything together. That's the whole point here. So we can create an index for order items, which is those order items, and it's nested underneath. So when we pull back, we will get a nested hash which contains the item ID and all those other fields that are on the order info. So we now have one object. And I'm going to quickly show you how I do this in my denormalizers. I'm going to have the code available, I hope, for download, and that you can take a look at it. So I create a toHash, because that's what's going to be called. And well, you can see that it's called here, toHash. And then we have all of these keys that we want to pass. And these are all the indexes that we've created in here in Elasticsearch. So we create all these indexes, and then I use essentially method missing, which is the, it will call that method on the object. And then you can simply, he says, create all the methods that simply return that thing from the purchase order, because normally they're on the purchase order, but not always, because some of these are kind of calculated. Like SKUs is a list. So we go through all the order items and pull out the SKU. We go through all the item IDs and pull out a list of all the item IDs. How many unique item IDs do we have? How many were ordered? So we go through the order items and sum them. So now they're all going to be there on the object, on the record inside of Elasticsearch. Now what you're saying is, okay, we had this other thing that was the nested info. So here's what I do for this. It will only call the top level. It won't call methods for underneath. So it's going to call order items info, because that's what I called it here, order items info. And I'm going to go through all of the order items on the purchase order, and I'm going to calculate a fulfillment fee, which is again, kind of nested inside. The order item knows about the item, and on the item is where we set the fulfillment fee and the unit cost. So we set the fulfillment fee times how many were ordered, and that's going to be our final fulfillment fee. So on like that. And I think we even have total costs. Maybe I didn't do it, but total cost would be, the number of items ordered times the cost of the item. So we fill in all of these things. Now let's delete the index again. There's ways you can do it without having to delete the index, but for the sake of use, let's just do that. Let's just pick one. Let's touch it and model purchase order 8. Did I do something not quite right here? Oh, bloody hell. Reload that. Just start over. There we go. Now let's go and take a look again. Let's update the thing. I'm going to just delete it. Deleting this index pattern from Kibana doesn't delete any data. It's simply the thing that Kibana sees. It's a bit silly that you need to have it twice over, but anyway. There you go. Now let's go over to Discover. Now we have our object, and here you can see the order items info is nested. And we've pulled out a list of SKUs and there, which is the SKU from there. Yeah. So there should be an item ID. Item ID is 3. That's the item ID from there. So there, we've got all of our data denormalized onto one row. That's a lot to take in. Man, I went a mile a minute on this. And I feel like I should do it again, but I hope you get the idea. So now we could do something. We're satisfied. We've got the data in the structure that we want to do. We can say purchase order import, and this is going to import all 5,000 records into Elasticsearch. You can see it's going off, and I'm not caching anything, so there we go. Now if we go and take a look, there we've got 5,000 orders in Elasticsearch, and right now it's showing it because we set a primary kind of sort, if you want, as index date, so you can see that it's gone back a month and done these. We say by day. I don't need to. Oh, let's just this auto, and let's just say what I knew I did it in the last 30 days, right? So we can go there. You can see that things are pretty evenly distributed, and then you can get into Kibana. I mean, Kibana is just it's just a tool for you. So you could do something like a pie chart. You can search purchase orders, and count on the bucket is terms, let's say a fulfillment center. So now we can see how many things were from each fulfillment center. It should be pretty even because of the way we did it. So now you're getting an idea of the power of Elasticsearch. So our item IDs, it's only choosing the top 5. So if we change this to the top 50, you can see these are all how many of this one was ordered, 23 of that, 191, 190. Yeah, it's all pretty evenly distributed. So there you go. That's my intro to Elasticsearch. Very fast, maybe very confusing. Should I do it again? Probably. Will I? Probably not. And I'm going to do another one which goes on and talks about non-active record models. You don't have to have your thing tied to active record at all. It could be completely independent. And how you could use this from the front end to search and all the rest of that stuff. I'm going to try to do another one about Elasticsearch if there's any kind of interest. Thanks for watching. Hope it wasn't too fast or confusing. Leave me a note, a comment, of course subscribe and like, hit the bell notification because I'm trying to bring you guys some good stuff. I'm just trying to show you the things that I use every day as a Rails developer. Talk to you soon. Bye for now.